You should not keep it a whole year. I know. I don't want to use it.
I love your sweater.
Thank you.
Thank you.
Thank you.
I feel like I want it.
I don't. It just
Am I too
falls
old
in my
for
closet.
it?
No. I think you really keep it.
It's so cute,
I
right?
really don't know where I got it from. It just spawned in. I think my brother's wife gave it to me.
Aww. All right, guys. So we are going to be graphing different polynomial functions. Well, it's more like sketching because it's not accurate graphs. So we're going to say sketching polynomial functions. Okay, so polynomial functions are continuous graphs. To graph, we're going to look at some things. The first thing we're going to look at is the end behavior. And the end behavior is what it does as x goes to positive and negative infinity. So it's really what's happening where it starts and ends. That's really what the end behavior is. What's happening where it starts and where it ends. Next thing we're going to look at are the zeros. And what do I mean when I say we're going to look at the zeros? Where the graph does what? Hits the x-axis. When I say we're going to look at the zeros, where the graph hits the x-axis. Okay. Let's talk about things that determine the end behavior. Okay, is the highest degree of the polynomial, and I'm going to put in parentheses expanded, meaning if it's like the quantity of x plus 1 squared, you want to consider it squared, is the highest degree of the polynomial expanded odd or even. And also, is the leading coefficient positive or negative? Okay, and then I'm also going to put a star. And we're going to say bounce or cross. And this means nothing to you right now until I actually do some problems. Bounce or cross. And we're going to say even is a bounce, even equals bounce, odd equals cross. Okay, so now let's say we have the highest degree is even and leading coefficient is positive. So I always say even slash positive. That's like the shortcut I write for that, even slash positive. What does that look like? So for even positive, do you guys remember quadrants? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So when we're even and positive, you're going to start in quadrant 2 and you're going to end in quadrant 1. An example of this would be y equals x squared. So this is just, I'm just talking about the end behaviors, start and end. Okay, so now let's say we have an even slash negative. What does an even slash negative mean? It means highest degree is even, but now leading coefficient is negative.
When you say it's even, you mean like the quadrants and like...
No, even means the exponent on the variable. The biggest exponent on the variable is an even number.
So you're forming those like parent graph equation things?
Yeah, well, it's just really all I'm focusing now is where the graph is starting and where it's ending. That's all I'm focusing on right now.
So that was confusing how you determined where it started and where it ended from the even.
Well, this is what we have to memorize. So when it's even and positive, it's going to start in quadrant 2 and it's going to end in quadrant 1. When it's even and negative, what you're going to do is you're going to start in quadrant 3 and end in quadrant 4. So when it's even and positive, you start in quadrant 2, you end in quadrant 1. When you're even and negative, you start in quadrant 3, you end in quadrant 4. An example of that would be y equals negative x squared. So all I'm focusing right now is the end behavior, where it's starting and where it's ending. That's all I'm having you focus on right now. So we did even positive and we did even negative. Now we're going to do odd positive. Okay, what does odd positive mean? Odd positive means leading coefficient is an odd number. I'm sorry, highest degree is an odd number. And leading coefficient is positive. So in this scenario, when your highest degree is an odd number and your leading coefficient is positive, you're going to start in quadrant 3 and you're going to end in quadrant 1. example of that would be y equals x to the first power, right? 1 is an odd number. It would look something like that. Start in quadrant 3, end in quadrant 1.
Would a disco dancer be valid?
Disco dancer would be very valid. All right, and the last scenario here is going to be an odd negative. So when we're odd and negative, it means the highest degree is odd, and leading coefficient is negative. And again, this is just talking about our end behavior. All right, so when you're odd and negative, you are going to start in quadrant 2, and you're going to end in quadrant 4. An example of this would be y equals negative x.
I thought if the highest degree was even,
You start at 2, but you end in 1. So even though you're starting in the same point, you're ending in a different point. All right, what do you think you should do with these? Memorize them. You want to memorize end behavior for all the different scenarios, even positive, even negative, odd positive, odd negative. And really, that's only just telling you where are you starting, where are you ending. Okay, so when we're sketching, we're going to look at the end behavior. And what was the other thing I said to look at? End behavior and zeros. Let's talk about what's happening with the zeros. I know, it's a lot of notes today.
No, but this is how much space I used, and that's how much space she used.
I mean, mine would probably look more like hers. That is super small what you wrote.
I like it when it's tiny.
It's pretty.
I know.
Okay, let's talk about zeros. For the zeros, what you want to do is you want to set equal to 0, then solve. But now there's a 0 that comes from an odd power, and there's a 0 that comes from an even power, and different things happen there. So a 0 that comes from an odd power goes through the point. And I call it a cross. A 0 that comes from an odd power goes through the point. And this will all make much more sense once we start doing problems. A 0 that comes from an even power will bounce will hit the point then bounce. Let's say that will hit the point then bounce. All right, are we ready to try some problems now? Not yet. Finish copying, then we'll try some problems.
What does it mean to bounce back?
You will see. Okay, our first example. I want us to sketch P of x is equal to x plus 3 squared times the quantity of x minus 1 to the 5th times the quantity of x plus 1 squared. Okay, so the first thing we're going to consider is the end behavior. And the way we decide the end behavior is we're going to look at the degree of the polynomial, but we have to look at the highest degree of the polynomial when it is expanded, meaning all multiplied out. I'm not going to actually have you multiply this all out. Think about it. If I am taking the quantity of x plus 3 squared, right, wouldn't it be times itself? So what would be the highest exponent here? X squared, right? This would be x squared. All right, then if I'm taking x minus 1 and raising it to the 5th power, meaning I'm timesing it by itself 5 times, do we agree the biggest exponent here would be x to the 5th? And then once again, I'm taking the quantity of x plus 1 and I'm raising it to the 2nd power. I'm taking it, I'm multiplying it by itself. So again, here the biggest exponent would be x squared. All right, now what are we going to do if we were multiplying? Wouldn't all these then get multiplied together? So x to the 2nd times x to the 5th times x to the 2nd is x to the 9th. Is that even or odd? Odd. So our end behavior is odd. What's the other thing we have to consider? Odd and positive or negative. Well, aren't all the leading coefficients positive? 1, positive 1, positive 1, positive 1. So positive times a positive times a positive is a positive. So we are odd and positive. Go back to your notes for the end behavior. If we are odd and positive, where are we starting and where are we ending for odd and positive? 3 and 1. So I put S and E. We're going to start in 3 and we're going to end in 1. No. Okay, so now we know the end behavior. We know where we're starting. We know where we're ending. Now we have to figure out what's going on in the middle. Okay, so what's going on in the middle? What you want to do is you want to look at the zeros. So you're going to take your polynomial. So part A was our end behavior. Part B is looking at the zeros. So we're going to have x plus 3 squared times x minus 1 to the 5th times x plus 1 to the 2nd. We're setting this equal to 0. And this is already factored. Sometimes we will have to factor, but this is already factored for us, which is nice. So that just means we take each one and set it equal to 0. So we're going to say x plus 3 squared equals 0, x minus 5 to the, x minus 1 to the 5th is equal to 0, and x plus 1 to the 2nd is equal to 0. Now at the zeros, we have to look at the exponents, even or odd. So if it's even, it's going to be a bounce. If it's odd, it's going to be a cross. So the first one, the quantity of x plus 3 squared, isn't that an even power? So that means this is going to be a bounce. Where is it going to be a bounce? You take x plus 3, set it equal to 0. So we are going to have a bounce at x equals -3. Then we go to the next one. And now we have an exponent of 5. 5 is odd, right? So is it a bounce or a cross for odd? This is a cross. Where is it going to cross? So you take x minus 1, set it equal to 0, and solve. So we're going to have a cross at x equals 1. Right, and the last one is, again, even. What does an even mean? Bounce. Where are we going to bounce? You take x plus 1, set it equal to 0, and we get x equals -1. All right, are we ready to now actually sketch this? Let's do it. So I'm going to first plot all of my zeros. So we have -3, 1, 2, 3. We have 1 and -1. So first 0 was -3. Second 0 was 1. And we have -1. All right, now we are starting, so we're starting down here, and we are ending up here. Do we agree? Start, end? All right, so if we're starting in quadrant 3, so we're coming from -infinity down here, which 0 are we going to hit first? Which 0 are we going to hit first if we're starting here? We're going to hit -3 first. So then we go here. What was -3, a cross or a bounce? Bounce. What does that mean? It means we come here, from here, we hit -3, but we don't cross over. We bounce back down. That's a bounce. Bounce back down.
I think I've done like this before.
Oh, you've done this? Yeah, you did it in Algebra 2. So then now what we're going to do is we're going to turn. Now when you turn, you do a curved turn. You don't do a V turn. You do a curved turn, like a rounded turn. And now the next 0 we're going to hit is which one? -1. Now is -1 a bounce or a cross? It's a bounce. So what happens? So we turn, we hit it, but then what happens? It bounces back down. Now we cross again. We have to turn again. Why do I have to turn again? Because I still have to hit that 1, right? So now I'm going to turn. You always do a curved turn, a rounded turn, not a V turn. And now when I hit the last 0 at 1 or at +1, is it a bounce or a cross? It's a cross, so you can cross straight through. And you put arrows where you start and where you end. And aren't we correct? We started in quadrant 3, we ended in quadrant 1. Yeah. All right, let's do another one where it's not factored for us. Maya?
It doesn't matter where.
It doesn't matter how high. Yeah, I'm not going to ask you to have a point, any points. It's just the general idea of how it's moving. That's all I care about. I'm sorry. Yes?
Your son said Fortnite.
Zeki does. Dean's not allowed.
I love Fortnite.
You love it?
Yeah, it came back.
So he's not going to ever stop it?
Yeah.
Great.
No, I stopped it for like 2 years and I came back on.
Oh. All right.
I relapsed.
I don't care for video games. All right, so let's do this. First thing I'm going to do is talk about our end behavior. Let's figure out our end behavior. what helps us decide the end behavior? The highest degree and the leading coefficient. What helps us decide the end behavior? The highest degree and the leading coefficient. So you guys tell me, the highest degree, is it even or odd? I heard two answers. Isn't this the highest degree is 4? So it's even, right? The people that said odd, what were you thinking? You weren't thinking? Is that what you said? Oh. Okay, so our highest degree is even. The leading coefficient, even or odd? Oh, you guys probably added 4 and 3. Who said odd? Well, somebody said odd. Were you adding 4 and 3? All right, you're not adding 4 and 3. I know why you think you're adding 4 and 3. Because on the other one, I did x squared times x to the 5th times x to the 2nd. Because these were all getting multiplied together. That's why. But here, this is already expanded and there's an addition sign. We can't add those. All right, so end behavior, we're even. What about the leading coefficient, positive or negative? Leading coefficient, so you look at your highest exponent and the number in front of it. Negative. So when we're even negative, go back to your notes. Where are we starting? Where are we ending?
3.
Starting at 3 and ending in
4.
4. You got it. Start in 3, end in 4. Okay, what do I say to do next? So we figure out our end behavior, which we did. Now what do we look at? Zeros. Let's look at our zeros. So we're going to take negative 2x to the 4th plus 2x cubed equals 0. We set it equal to 0. So the other one was nice because it was already factored for us. This one we need to factor. So what should I do? I should pull out a GCF first of negative 2x to the 3rd. You got it. And this is going to give me x minus 1. And now we take each 0 and set it equal to 0. Or sorry, each factor, I should say, and set it equal to 0. Okay. So you all tell me this first 0, negative 2x to the 3rd equals 0. The exponent on it, even or odd? Odd. So is this a cross or a bounce? This is a cross. Where is it going to cross? You have to solve this. So you're going to divide by negative 2. And we're going to have basically x is equal to 0. X cubed equals 0 is the same as x equals 0. We cubed root both sides, still get 0. And then we're going to have x minus 1 equals 0. Again, are we even or odd? Odd. So it again is a cross. And this time, where is it going to cross? At x equals 1. Are we ready?
No.
So ready.
Okay. 0, 1. So we're starting bottom. So we're going to go through. We're going to turn and then cross through again. So it looks something like this. All right, how about you guys try one? But it's going to be a little bit more difficult, but you can do it. What do you think eventually I'm going to tell you guys you have to do with this one? Factor it. Why are you going to have to factor it? To find the what? To find the zeros. Is this still included to find the zeros also? Yes. Maya, what if you mess up?
Usually I just like try and see what I'm doing, just kind of like wait. I like explain everything so I don't mess up.
Gotcha, okay.
Wait, for the previous one, why was it even?
For the exponent?
Yeah, why was it only 4 and not 3?
You mean not 7? Or
Yeah. But
okay.
Only
So you always pick the highest exponent once it's multiplied out.
Oh.
So what we had done before, the reason we had multiplied them or multiplied it all together was because it wasn't already multiplied out. So I was saying if we were to multiply these all out, it would be x to the second times x to the fifth times x to the second, which gave us the x to the ninth. But this one's already all multiplied out. So then we just pick the highest one. Who thinks they know what they're doing? Yeah. All right, so we need some guidance. All right, let's do this. So the first thing we look at is what? What am I going to ask you to analyze? The end behavior. Now the end behavior is the highest degree once everything's multiplied out. Is everything multiplied out right now? No, everything is not multiplied out. If we were to multiply everything out, wouldn't we have to distribute this one in? And then that would be 2x to the second times x to the second, which would be 2x to the fourth. Wouldn't that be our highest degree? So 4, is it even or odd? Even. And then the leading coefficient on that x to the fourth, is it positive or negative? Positive. So if we are even and positive, you tell me, where are we starting, where are we ending? Good. We're going to start at 1, we're going to end at 2. All right, the next thing I'm going to tell you to analyze is the zeros. Now for the zeros, what I want you to do is I want you to take that polynomial and set it equal to 0. But now you want to make sure it's completely factored. This is not completely factored because I can factor x squared plus 2x minus 15. That's going to give us an x plus 5 and an x minus 3. Now is it completely factored? Yeah. So now you take each one of these and set it equal to 0. Am I going too fast or are we good? Tice, you good? Okay, so for the first one, we're going to have 2x squared equals 0. So we also look at the degree, right? What's the degree of this, even or odd? Even, so this is going to be a bounce, exactly. A bounce at what? X equals 0. Then we have x plus 5 equals 0. Is this a bounce or a cross? Cross. Across where? At x equals negative 5. And then we have x minus 3 equals 0. Is this a bounce or a cross? It's a cross. Where is it a cross? At x equals 3. Do we have everything we need to now come up with an idea of a sketch? Yes. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so we have 0, negative 5, and positive 3. Those are our 3 zeros. based on our end behavior, we are starting in quadrant 2, ending in quadrant 1. So now, if I'm starting in quadrant 2, that means I'm coming from up here going down, right? So if I'm starting from up here coming down to hit my 0, which 0 am I going to hit first? The -5. Now, is that a bounce or a cross? It's a cross. The -5 is a cross. So I cross the point. Now I curve turn it, right? I don't make a V-turn, curve turn it. Now I curve turn it, what am I going to hit next? 0. Is that a bounce or a cross? So I hit the 0 and then I bounce back down. And the last one is x equals 3. Is that a 0 or a cross? I'm sorry, a bounce or a cross? Cross. So you come back up and you cross again. So do you see how this was our original polynomial? So you want to, when you find the zeros, you want to make sure it's factored completely. This is not factored completely because I can factor x squared plus 2x minus 15. What multiplies to 15 and adds to 2? 5, and I just factored it, yep. All right, there is one more problem we need to do, and then we will call it a day. So write an equation of a 7th degree that satisfies the graph. I know. Write a degree. Oh, sorry, write an equation, not a degree. Ooh, Maya, did you write that word down already?
What? No. I'm still looking at my phone. I'm just looking at my notes.
Write an equation of the 7th degree that satisfies the given graph. And I'll give you the graph.
It's too hard.
It's not that bad. But I am going to add another element that makes it a little bit more involved.
Why do this to us?
Oh, why are we freezing? Don't freeze on me. What? Why did it all just erase? Guys, what happened?
I don't know.
You saw me draw it. Oh, now it's back.
How come it's going to the y-axis? It's crazy.
I know, I'm wild.
That's not even allowed.
It's allowed.
I thought a 0 is just going to the x-axis.
Well, it's not a 0.
What is that?
It's a y-intercept.
It's like
It's crossing the y. It's just a point. It's another level that I'm adding into this. It's another level I'm adding into this. Okay, guys. So we're saying write an equation of the 7th degree. So that means if all the exponents, when you multiply it all out, it has to be a degree of 7. Let's look at this. I'm going to go through and I'm going to identify my zeros. Do we all agree this is a -3? It was -3 and it was a bounce. Do we agree? So was that even or odd? Even. So I'm going to write even. Then we're at -1. This one's -1, but it's a cross. Since it's a cross, is that even or odd? Odd. So I'm going to write odd. The y doesn't count. The y doesn't count right now. We'll deal with the y later. Now go to our last 0. This is +3. Is it a bounce or a cross? It is a cross, so is it even or odd? Odd. So do we agree our zeros are x equals -3, x equals -1, and x equals +3? I want to turn these back into factors. So these are zeros. To turn them back into factors, you make it, set it back equal to 0. So what I'm going to do is I'm going to add the 3. So wouldn't this become x plus 3? To get that to cancel to 0. And then what should I do with the x equals -1? What should I do to bring it back over? Plus 1. And then the last one will be x minus 3. All right, so now we got the factors. Now we have to figure out the degree to put on them. So the first one was an even. So what can I put on top of that? A 2. That's an even exponent, right? An even degree. The next one was odd. So can I just leave it with an exponent of 1? Is that okay? All right, and the last one, again, was odd. Can I just leave that with an exponent of 1? Yes, but now check. What did I want a degree of? I want a 7th degree. This is 2, 3, 4. Is that a 7th degree polynomial? No. So we have to change something. Any ideas on what we can change? Good. If I make one of these have a 3. Oh, wait. That doesn't add up to 7. I missed something. Okay, sorry. A 6th degree polynomial. Sorry. I didn't even do it on purpose. I'm so sorry. I didn't do it on purpose.
No, I know, but you didn't even do it. Whatever.
Okay, and now we're going to set this equal to 0 because it says an equation. We're not done yet.
Couldn't we do 7 if it was just 5?
What happened?
If the 3 was a 5.
But then this would be a 1 and that would make it an 8. So it wouldn't work. But you could have put the 3 on the x minus 3. One of them had to be 3 and one of them had to be 1. We're not done yet because now, if this is our p of x, we have p of x equals x plus 3 squared, x plus 1 cubed, x minus 3. But now, what else do we have? We have this point. What are the coordinates for this point? Isn't it 0, 4? So this is telling us we need p of 0 to equal 4. That means there's going to be a GCF. That means I'm going to have a times x plus 3 squared times x plus 1 cubed times x minus 3 has to equal 4. But what should go in for all the x's? If p of 0 equals 4, what should go in for all the x's? 0. Because it's telling me p of 0 has to equal 4. If I plug in 0 now for all of these x's, I'm not going to get 4. So now we're going to have 4 is equal to 9 times 1 times 9. A times 9 times 9. So here we're going to have 81a. How do I solve for a? Divide by 81. So a will equal 4 over 81. Nico? Oh, it's not 9. That's just a degree of 1. I'm sorry. That's a -3. This is a problem.
This bit here, yeah, negative 3.
Because this would change our whole... Guys, there's a problem here.
Guys.
I need it positive. I know. All right, let's
Cancel this. No more.
I know, we need to cancel it.
Done. Get rid of it.
We need to cancel it, but I need it to be positive.
Yeah.
Okay, to be continued. We'll do a new problem. It's the same concept. It's